Hi everyone. So I hope you are excited for one of the last remaining talks for the ArgoCon. Now, this is a quick question. How many of you here work with AI models and AI model inferencing by any chance? And have anyone of you actually used Argo workflows for machine learning inference? All right, perfect. So, of course, like today's talk is going to be centered around the theme of how do you make machine learning model packaging and also inference and deployment more scalable with the help of KitOps. If you've not already been aware of KitOps, we will be introducing this. It's a new CNCF project as well, and we'll be talking more about Argo workflows. So I'm Shivay, I'm one of the CNCF ambassadors and one of the lead contributors to the KitOps project. And with me, it's Ekansh.
Hi everyone, I am Ekansh. I hope everyone is able to hear me. I am a software engineer and maintainer with SigNoz, and SigNoz is an open source, open telemetry native observability platform. And we are very excited for you to be here. So let's get started. So what is the problem with like production grade machine learning models? So the problem with production grade machine learning models is that 80% or more of machine learning models never go to production. And why is that? And the reason is because it's very difficult, it's very complex, and the deployment is even more difficult than doing the inference. So that's a big challenge for us. And what is the biggest challenge today with machine learning packaging? So the biggest challenge are a couple of things. And one of them would be that it has a lot of parts. So and every part is getting stored at a different location altogether. So if we talk about models, so models are being written and stored in Jupyter notebooks or any other editor or something like that. If we are going to talk about data sets are going to be there in your data lakes, databases, or some blob storage or some place like that. And if we talk about your code, the code is stored in Git repositories, so it can be GitHub or GitLab. And then there are metadata which has like scattered parameters, and it has a lot of weights and features, and it has like a whole lot different storage systems altogether. So if we talk about all, so we need or require a lot of open source projects just to maintain one AI ML project if we do not want to go towards vendor lock-in. So that's the challenge of packaging and containerizing of AI ML projects. Yeah, so why can't we use the same pipelines, the same methods a DevOps person would use, a DevOps engineer would use for MLOps or AI MLOps? So there are three things that I would want to mention here. So the one is the nature of the project. So it can be very difficult, it can be very complex, it can have a lot of different things. It can have like some part is being trained, it is getting back to that retraining position. It has a whole lot of moving things that we need to see. And for a DevOps person, DevOps is very declarative way in like this part will execute first, it will give me this result, and that Y result will like give me a Z product altogether. And for MLOps, we need a lot of individual expertise. People should know about ML, people should know about AI, and with the whole ongoing uprising of AI ML, we are getting there, but still we need a lot of expertise for AI ML workflows. And the third one is the size and complexity. So we all know that AI models and even the training parameters need a lot of space. It can have like 10 billions and 100 billions of parameters, and even more space to just store and inference them.
Yeah, so basically the idea is that if you compare a traditional software pipeline, it is drastically different than a traditional machine learning pipeline, because in machine learning, you need to do a lot of experimentation, a lot of training pipelines where you're continuously changing your data sets, you're changing your models to be able to get the exact prediction. So that nature of how these machine learning projects basically operate is classically different than a traditional microservice-based architecture that you traditionally have in your DevOps pipeline.
So, so the deployment of AI and ML models is tricky. So the first part is, why is it tricky? So we need a lot of GPUs. Currently, as a DevOps engineers, I do not have to work with GPUs. But as a ML engineer or an MLOps person, I need a lot of GPUs just for inferencing, just for training, and just to run it through. Right. The second one is that there is a separate DevOps architecture as compared to our deterministic like AI models, like non-deterministic AI models. We have to train, we have to go retrain, we have a lot of parameters, we have weights. One model's probably like output would be another model's training model. So yeah, there are a lot of non-deterministic nature in AI models.
And to probably add on to this point about observability as well, because there are things like data drift or model drift, which means that your degradation of your performance of the model, so your observability metrics that you're trying to get, like let's say you're trying to show them on SigNoz, then you'll have to add some additional parameters in order to be able to visualize them, because it's not going to be the same kind of metrics that you will expect that you have in a traditional pipeline. So basically, let's walk through.
Yeah, so let's walk through. Shivay will help us walk through of how we are going to secure AI ML package model packaging. And we are going to also see how we are going to deploy and run large-scale inference for AI ML models.
Using Argo workflows. So first, let's talk about the packaging part, right? Initially, we mentioned that one of the biggest challenges that we have today is that there are so many different moving parts to a machine learning system, and you generally need different kind of open source projects to be able to take care of all of those different parts. So as for example, for tracking, you'll use something like DVC, which is like distributed Git in a way. And normally, if you look at Docker as the go-to platform for being able to containerize applications, Docker is great. Like, we're not saying Docker is dead for AI. Like, in fact, a lot of folks over here might have actually deployed or containerized a machine learning model with the help of Docker. But where does Docker not really get up to the mark where we need it is because it's not purposely built for machine learning. Because of the advent of these large language models, there are a lot of different critical aspects where using just Docker will not call it a day. Because, like, let's say you're trying to build an agentic system. So there you're not only trying to change the parameters of your machine learning model, but you're also trying to change things like prompts. Maybe you are trying different kinds of prompts. So you're dealing with prompt versioning, you're dealing with dataset versioning, you're dealing with your model weights versioning. All of them are being changed interoperably, and you want to be able to essentially tie it together where you can have a proper audit trail of what things are actually happening. So there's going to be a really great talk during main KubeCon by Yash from ChainGuard, who will talk about how you can secure machine learning pipelines, and that you can visit his talk as well. But the idea is that there is not really a built-in solution that can tackle all of this. And that's why in April this year, we had this introduction of a new CNCF project called as KitOps. So it's still a sandbox project, but the idea here is that it's trying to build on where Docker could not really fulfill the promise of machine learning. And it essentially can take up all of the different parts of your machine learning model system and package them together into a single OCI artifact. And that means that you can still use it with your existing DevOps pipelines and also deploy it on any OCI registry. So basically, once you package all of the different parts of your machine learning system into a single OCI artifact format called as a model kit. So model kit is very similar to like a Docker image, similar to how you have Docker build, where you take a your Docker file where you define your entry point, all of the files that you are going to be having in your container image, and then you do a Docker build to create the image, and then you do Docker push to push it to in any container registry of your choice. Similarly, KitOps follows a very similar paradigm, and it's purposely built for machine learning, right? So you can use existing registry tools or even OCI specifications that are purposely built. But the great thing is that it takes specific care of being able to track. So for example, if you're having like, let's say, different version, or you're tagging different Docker containers, every single different tag in your model kit could represent a different version or experiment that you have run with machine learning, so that you can always go back and have a proper audit trail in terms of understanding the performance of the machine learning model. So that's the core idea. Now, there are three major components of KitOps: the model kit, the kit file, and kit CLI. Kit file is like the manifest. So the idea is that you can declare all of the different components of your machine learning system as declarative YAML. And here you can see on the right-hand side, we start by saying package, we give it a name. So that's the name of your model kit. And we define what are the different components we want to package together as a single OCI artifact image. In this case, we have the code, we have the dataset, and the model. So the idea is that by packaging all of them together, you don't have to worry about having to use different open source projects and having to like pull information of different things that you have in your machine learning project, because we know it's like a large puzzle. So the idea is to be able to package all of them under one single roof. And similar to how you have layers, right? When you create like let's say Docker image, the different layers in a KitOps model kit represent the different parts of a machine learning system. And it makes it super simple to be able to encapsulate all of your different necessary information under one single roof. And as I mentioned, like this is an example of the model kit. So here you can see that the kit file is like your Docker file, right? And model kit is what your OCI artifact is. So it's very similar to like a Docker image, but this is the components and some of the media types that we have, which are purposely built for machine learning. Now, of course, with Docker, there is also the launch of Docker Model Runner, which also introduces its own set of media types inside of OCI artifacts that allow you to be able to run machine learning model inference with, like, let's say, GGUF models. So you also get some specific media types that are purposely built to be able to do machine learning inference as well. And you can see, like, you get proper immutability, and every single component of your machine learning system is its own layer, as we mentioned earlier. And the idea is really for us, and a lot of different other companies like Alibaba, Red Hat, Docker, Zozu, all of them are basically trying to come up with a singular packaging format. And this is another project within the CNCF called as Model Pack, where we are basically setting the guidelines of standardizing how your OCI artifacts should be built. Because today, if you try to download a model with Ollama, it wouldn't run with Docker Model Runner or maybe with LM Studio. So every single company is trying to make its own OCI artifact format, and we're trying to standardize that. And that's our aim, to have an open standard for being able to package machine learning models, and especially LLMs, as part of this larger initiative within the CNCF. So if you're more interested in that, please do reach out to me.
Yeah, so coming back to Argo Workflows, because we are in ArgoCon. And yeah, so what is Argo Workflows? I am pretty sure that most of us might know what Argo Workflows is. So Argo Workflows is a Kubernetes native workflow engine. So it helps us to create some DAGs, some workflows inside Kubernetes. It's Kubernetes native, and it is useful for ML and AI pipelines, CI/CDs, probably data processing, some infrastructure automation. And Argo Workflows is implemented as a Kubernetes custom resource definition. So we can actually do a lot of things with the declarative way of how a CRD is made. So we can probably run up a new pod, we can run up on like a volume, we can just get a lot of artifacts from certain registries, we can create a new DAG, and we can get one model's output to another part in the Argo Workflows branch. So let's talk about a practical scenario.
Yeah, so the idea is very simple, that we'll take a machine learning model, we will convert it into a trained model artifact with the help of KitOps, and then we'll create a deployed inference service with the help of Argo Workflows. But the idea is to showcase a really simple example, but you can very easily scale this up with some of the more advanced functionalities that you will get within Argo Workflows. So here's a simple diagram. So initially what we are going to do is that we will show you, okay, we have a trained machine learning model. It's a simple sentiment analysis model. Then we use KitOps to package and build the model kit, which is our OCI artifact that contains all of the different components of your machine learning system. Then we upload it to Zozu Hub. So it's like Docker Hub, or in fact, you can use any OCI registry that you want, whether it's a closed, a private, or an open registry. And finally, we show that once your model is ready and deployed as a package container image, how we can use that as part of our Argo Workflows for doing the inference. Yeah. So here, initially what we are doing is that we have taken a text classification model, and we are using sklearn or scikit-learn to train the machine learning model. At the end, we get a .pickle file, so .pkl, which is the actual machine learning trained file. And you call this to do the inference of the machine learning model. Then what we're doing is that we are basically creating our kit file. So this is what is being used to take our machine learning model and the components and package it as a model kit. So here, generally what you'll do is we will use this kit pack command. Now this kit pack command, if you look carefully, it's very similar to like a Docker build, right? So you do Docker build, you give it a tag, then you give the name of the registry, then the name of your repository, and then the name of your actual, and then probably like a tag, which is like latest, v1, v2. So here, by doing this, you just say, okay, like these are the different components that I have. And in this example, we are taking the model file itself, the requirements, and some sample inputs for being able to do things like batch processing. And once you do this, you can package your machine learning model and you can upload it to a registry like Zozo Hub.
Yeah. So let's talk about what the workflow template is going to look like. So let's just say we have a Argo workflow YAML. So we have previously discussed that we are going to create a CRD. So it's going to be a reusable template such as a YAML template. And we are going to use a lot of steps. So it can be something like starting an input, probably calling the inference container from Jozu. We are going to download artifacts from like registries. We are going to process the outputs and then collectively aggregate those results. Let's look at a template as well. So in this template, we see that it is a single inference text classification model. So if I see here, we have written a text classification model. If we go down and check what is going on here, so we have started some containers and the model kit file is getting downloaded or like unpacked from the Jozu hub. So very similar to Docker hub as we have already mentioned. And then we are just going to mount a volume and we are going to run a normal inference like Python command on the particular DAG.
Yeah, so basically the idea here is that in our Argo workflow, we have defined where exactly or what container image we are going to be using. So in this case, we are having the model kit, which we are unpacking. Unpacking is like doing a Docker pull, where you're able to get all of the different things that are there in your container image. So the kit pull command will be able to give you all of the different components of your model kit. And then we just use and we mount it inside of our volume, inside of our Kubernetes cluster. And then we just run a simple Python inference command from our unpacked model, because we have the unpacked model and also the script to be able to do the inference with the model. And this allows us to execute this as part of our inference workflow. So this is a single inference workflow.
Yeah. Let's go ahead and we are going to check like what happened in this single inference workflow. So we see that we have like so we have done some sentiment analysis. So we have like negative and positive probabilities. We are done with the pod initialization. We are done with all the like inferencing. We have the result as well. If we go to the next slide, we have a video for the same. So let's go here and we see that we have that inference. We are going to run those inference model in this particular terminal and we see a new pod coming up. So it has succeeded and one pod is running as well. Now we are going to just check the logs for that pod, which has been completed right now. So which was this one, the single inference model. And if we go and check the logs of that pod, we see that we have a negative negative probability of that sentiment because the because the statement that we gave in the machine learning model was of negative sentiment. So it gave us a negative sentiment for that. Coming back to batch inferences workflow. So now, till now, we have shown you single inferences. So single inferences might be good. It might be good for like smaller personal projects. It might be good for like smaller workloads, but in a production use case, we are always going to use something like a batch inference workflow. And this is where the DAGs or the directed acyclic graphs are going to come up. So we are going to have a lot of inputs. We are going to start from a single part in the DAG and we might branch out. And in that branching out, we might see, yeah. So if we see the DAG here, we have started with generate tasks. We have a lot of inference tasks as well. One particular, like it would be branching from the root of that particular DAG, and it might go into a task A, it can go into a task B, and the results of those particular branches will come down to an aggregate result part, which has been named as aggregate result here. And the output is going to be aggregated or like aggregated from that particular flow. So if we see here, we have a lot of processing done. So we have processed text and a couple of branches that there are there. And the result of these branches are going to come down to the final node, which is the aggregate results. And the output is going to be aggregated of all the nodes that are there in this particular diagram.
So the idea is that if you have like a sample data, here you can see a sample JSON data of having like 6-7 different examples, and you want to do parallel execution with all of them. So with the help of the DAG that you get within Argo workflows, you can do parallel inference across multiple nodes at the same time. So this saves you a lot of time, because it's also really useful if you're doing multiple experimentation runs, because as you know that machine learning, you're tweaking your parameters multiple times. There are a lot of hidden edge cases that you might come across depending on how the data you're basically using, because generally machine learning models are always trained with a like really small subset of data. But when you introduce the machine learning model to a larger production ready data, then you see the model performance really plummeting.
Yeah. So this is just the output of what the batch inferences is going to look like. We are going to see a demo in action right now.
Yeah. So I'll just quickly show all of you, like we have already shown some parts of it, but I just wanted to dive a bit deeper into like showing one example. So I just created a simple sample file here, which I'll just quickly open up. So I have this sample MD, and I'll just quickly show an example, live example. So here, let me zoom in a bit more. So here we are going to be creating a simple, we are going to be using the single inference workflow YAML. And if you're curious to see like what that looks like, so that is the workflow. So here we already described to you that we are unpacking our Zozu, from Zozu we are unpacking the model kit, and then we are running the inference here. So I'll run it by saying this is terrible and disappointing, right? So I start to do that. I can take a look at my current set of workflows that are already there. So you can see that this current one is running, and I can just do a watch to see in real time as it is completing. And once it does complete, then I would just simply in the meantime go ahead and copy this over, and because I also want to run it with, I want to see the logs that we are getting. So here I will just simply go ahead and replace it, the name of that particular workflow. So here I can go ahead, and I think it should be completed by now. If I just exit out of this, I can see, okay, yeah, it has been succeeded. So now I can go ahead and take a look at the logs. So you can see over here that it gave us negative because it was terrible. So it gave us a sentiment. And this Argo workflow would also show up here in our list of workflows, which the one that we just ran like 1 minute ago. So this is what, I mean, it's a single inference. That is why it's looking very simple. But we also had like another example of doing the batch processing. So I didn't have enough time right now, but the idea is that we are creating a config map for our batch processing where we load our sample inputs.json file, then we apply it. Then we are able to, like, if you see here, describing the workflow, it will show the list of all of the individual tasks that ran. Maybe I think it's already done, so we can ignore that. But yeah, the idea is very simple, that once you describe this workflow, you can see all of the different tasks that ran separately and parallelly, which you saw in our existing example here, right? So basically that's being done or being handled here. And then we have logs to look at every single individual task that you ran parallelly at the same time. So that's a quick demo of this in action. If you want to have the GitHub repository, we will be happy to share that as well. But let's take a look at some of the more advanced patterns thanks to Argo workflows.
Yeah, so why are we using Argo workflows? It can be done with any workflow engine, right? So first of all, why Argo workflows? One, because it is Knative. Secondly, with Argo workflows, we can do a lot of things. So we can have multiple models running at the same time. So we can have a model A, some branch of our input is going to model A, the other branch is going to model B, and then there is another branch in this particular decision where there is going to be a A/B testing sort of thing. The outputs of model A is going to go somewhere, then the outputs of model B are going to be taken in, and we are going to compare those results. We are going to aggregate those output. We are going to probably store those results in Jozu Hub or some artifactory. And then we are going to just visualize everything on Argo UI.
Yeah, so the nutshell is that if you're trying to build an ensemble of models or mixture of agents, mixture of models where you want to be able to like get multiple pipelines running and output of one model is being fed as input to the next model, and you have an architecture that basically uses multiple models at the same time, you could use the Argo's branching technique to be able to scale and deploy that kind of complex machine learning workflows as well. But just to recap, as we are in the last 1 minute, so as we basically covered today, that we can package our machine learning models very easily with the help of KitOps, which is a new open source project from the CNCF. And as compared to other like existing solutions, it provides a very opinionated manner of being able to package machine learning models. And we can also combine it with Argo's parallelism that allows us to run multiple concurrent requests at the same time. This means that if you're doing rapid experimentation and want to scale it and be able to run parallel jobs, you can do that with the help of Argo. And with KitOps, you also get governance. So more about signatures and security. Again, I'll recommend you to watch Yash's talk at KubeCon. He talks a lot about that. And finally, with Argo, you also get a lot of workflow resilience. And that's the reason we wanted to show how you can scale up machine learning inference with the help of Argo workflows. So whether it's like the routing, the parallel execution, all of those help you to scale your machine learning experiment and inference jobs. And of course, since it runs under the hood with Kubernetes, you can use GPUs and running GPUs on pods. All of that can be met very nicely. So ultimately, what you get is you secure your machine learning models and package them in a very efficient, purposely built format with the help of KitOps. Then once they have been declared, you can do the inference with the help of Kubernetes and manage the inference thanks to Argo workflows with the built-in resiliency, the DAG architecture. So this helps you to go from zero to end. So right from how do I package my machine learning models to finally going in production, all the way from 0 to 100 with the help of this kind of an architecture. So thank you so much. We'll be here for answering any questions.